Hey everyone, happy Happy Wednesday. As usual, let me know if my definitely let me know if my sound is doing pretty good. I didn't get a chance to do any sound tests before. Mic is a bit low. All right, let me turn that up a little bit. Let's see, is that let's see, clip. Hello, hello, hello. Is that a little better? Is that too loud? Okay, better. Perfect. Cool. How's everyone doing today? Definitely let me know in the chat how you're doing today. I am doing pretty great, actually. I've been waiting for a long time to get to go axe throwing. I don't know if anyone's been axe throwing, but a team at my job got to go today, and I got invited along with them. And I got to do a little bit of axe throwing right before this, so I'm a little bit amped. That was pretty fun. I'm definitely planning on going back, taking a bunch of people. It was very fun. Surprisingly, we only got to throw, I didn't know there were like large full-size axes that we got to throw at the end, and I was a lot better at that than I was at the smaller axes, but it was pretty dope. If you haven't been, I definitely suggest taking some time to get out there. As usual, we'll give people a minute or two to kind of get settled, get in, grab some food, grab a snack or something, grab some water. You know, I have my water chalice, a mastermind water chalice here, you know, for when I get thirsty. But yeah, grab some snacks, relax, and I think tonight's stream, I'm hoping, you know, I called it wrong last time, but I'm hoping tonight's stream is going to be a little shorter than the last stream. There's a lot of cool stuff here. We can make it as long as we want, but I think this one might be a little bit shorter, hopefully. I'm probably expecting this one to be between an hour and a half and 2 hours. I'm really going to be aiming for an hour and a half for this one. I'll let you know shortly what we're going to go over, but yeah, probably around an hour and a half. And again, no big deal if you can't watch all of it. You can hop off. This is recorded, and it'll be up on Twitch for at least 14 days, and then I'm recording all of them, so I will get them up on YouTube. I'm in a playlist on YouTube so that you guys can watch at your convenience after that. Cool. Okay, so it's working. So last time, I need to do a little more work in the chat section. You can see how people's names are like duplicated in the same color. I try to put in a little bit of code, a little bit of JavaScript in there to get everyone's name to be different, so it will be easier to kind of disseminate between each people's names. But it doesn't look like that's working quite right yet. I think last time they were all green, so I think we've made a little bit of progress, but we're getting there. But cool. So for tonight, maybe I'll just pull up the curriculum really quick, just for what we're going to be going over tonight. So tonight, we're going to hop straight into programming. So we're going to be doing the introduction to programming. We're going to be going over some computer science basics, and then some specifics of, you know, dynamic versus static type languages, compiled versus interpreted languages, and then we'll do kind of a general programming language overview. We also will go over some text editors and IDEs. So these are the ways to actually, this is the way you're actually going to write code. And that part should be fun. Part should be a little bit hands-on. But what I did want to do is I wanted to go over, I think last stream, I forgot to go over, someone asked me about computer specs, and I think I forgot to go over that. So this course was designed for you to be able to participate with, as long as you just had a modern web browser, you can participate in this in these courses. The only thing that'll be weird for you is the Docker section, but I think I found a solution for that. But I'm messing around with it, making sure it's going to be feasible. But ideally, so a modern web browser is the minimum recommended requirements for this. Ideally, you would like to have a modern, up-to-date Windows 10 computer, Mac OS, or a computer running Linux, preferably Linux or Mac. I'm going to be running, so the VM I'm running here is a Linux VM. So if you want to follow along exactly with the commands that I'm doing, you will need to be on Linux, and I will show you as soon as we get to the Linux section, which is the very next section after programming, how you can do that. But you should be able to follow along with the programming section, not having Linux installed. But I will show you how to install Linux there if you can. Really, computer requirements. If your computer's from the last, I would say, 7 or 8 years, you should be fine to do most of this stuff. Hopefully you have at least 4 gigs of RAM and a little bit of hard drive space, but besides that, this won't be super intensive on your computer. But again, there are ways there are some servers we can rent. DigitalOcean has $5 droplets. Amazon, when we get to the AWS section, actually has a free tier for their servers that you can use to run all the things that we're doing as well. So I wouldn't sweat that too much. I will do my best to give you, when we're installing things, when we're doing things that are, I guess, operating system specific, I'll do my best to give the resources for how to do it on all of the operating systems. Most of the things that I chose to use are available on Mac, PC, and Linux, so we shouldn't have a problem there. A Raspberry Pi 4, you can use a Raspberry Pi 4 if you really wanted to. Ideally, if you're using a Raspberry Pi 4 as your, you could definitely use a Raspberry Pi 4. I think there's a Docker package for Raspberry Pi, so I think you would be good all the way through. And I think the new Raspberry Pis are pretty quick, so I think you will be good to go with that. Well, we have the vids up. I think by default, I think the video on demands stay up for 14 days. I'll see if I can get them to stay up for 60. I'm not sure if my account is yet eligible to stay up for 60 days, but I'll do my best to figure that out. But yeah, so let's hop straight into it, actually. So again, as soon as we get to a new section, we're going to start out with slides. Tonight is going to be, the last time was very slides heavy. This time is probably medium amount slides heavy, but we'll be hopping in and out of slides. We'll actually get hands-on. We'll actually be writing some code tonight, messing around with a few different programming languages to kind of get across the concepts that we're trying to learn. But tonight is mainly about the concepts. You do not need to, this is not going to be an entire computer science course, but it is going to point you in the right direction to some computer science topics that I think are important for you to know, and that will help you in your technical journey, whether it be DevOps or whether it be something else. Even if you want to get into software engineering or web development, I think these topics will help you. And I'll also give you the resources from here to dive further. So if you want all of that computer science background, you can absolutely go out and get that for free. The information is out there. I can point you in the right direction for that. But you do not need to be a strong computer scientist or have a great computer science background to do DevOps or to do a lot of things in tech. But you do need to understand how code is used to solve problems, and that is what we're going to be focused on tonight. So let's hop in to this. Let's go ahead and hit F11, get full screen. Cool. Intro to programming. I hope everyone knows the reference here. This is the Matrix. You're the one, Neo. All of you right now are Neo. And this is your journey. In the beginning of the movie, they find Neo kind of sleeping at his desk. And this is your journey into program, into tech. So we're gonna hop straight into it. You're already here. You're already watching. You've already decided to take what I believe he took was the blue pill. Don't really know which pill was for what. Haven't seen the movie in a while. But you already took the blue pill, so you are along for the ride. So let's talk about what programming is really. So really all programming is I stole this straight from Google. It is you providing a computer or other machine with coded instructions for the automatic performance of a task. So very simple. This is, you are, when you are programming, when you are coding, you are giving the computer a set of instructions so that it can perform a given task. So whenever you are coding and programming, you will be trying to get the computer to do a task. You'll be trying to solve a problem by making the computer do something very specific. And there are a lot of ways to do that. That's a good. Are you telling me I'll be able to catch exceptions? For anyone who hasn't seen The Matrix, you really need to go see The Matrix. It's a great movie. You'll understand that line with Neo asking if he'll be able to catch bullets once he found out he was the one. But yeah, definitely go check that out. But cool. How do we give a computer instructions? So computers, they're not people. How do we give it instructions? And we give it instructions by writing programs with one of these languages. So there are a lot of programming languages out there, and the way that we give it instructions is to type up instructions for it and pass it to a computer. Cool. How does the computer understand our instructions? So this part's going to be computer science heavy. This part is like all of this is going to be the parts that may take some time to really comprehend. But Very high level, a computer understands our instructions through translations. So just like you may translate English to Spanish on Google Translate, a computer actually does the same thing. So we start with the source code. We're going to talk about each of these in a little bit, but we start with the source code. That gets either compiled down to or interpreted to either bytecode or machine code. And so, yeah, it's just a translation process that happens in between for a computer to understand your instructions. So, source code. We had those 4 things there, or 5 things. Source code. What is source code? Source code is the human readable code that you will be writing, that all of us will be writing. So this is the part that we're going to be learning. We're going to be learning how to speak this language. Human readable source code, and this is in languages like Python, like Ruby, like Java, like JavaScript. This is the code. These are the things you're going to be focusing on. These are the concepts that you're going to be learning are created from the source code, and you're going to be learning how to use this source code to solve the problems that you want to solve. So if you look in here at this image, this may look foreign to you, but you know these words. Like, there's nothing crazy here. You know, this is the word range. You may not know what that means, but you can read that word. It's not a crazy symbol you've never seen before. It's plain English, printing range and check the range, and there's brackets and there's parentheses and things like that, but there's nothing like really crazy here. Maybe you don't know what this is, but it's just 2% symbols next to each other, but nothing really different from the things that you've seen before. So you would be able to go in and you would be able to read what this is. Cool. And so we talked about the next step being compilation or interpretation. What's a compiler? So a compiler is a very complicated piece of, well, I don't say very complicated, but a complicated piece of technology that does the translation. So it translates that source code into machine code, which is binary, or into bytecode. Machine code and bytecode are 2 different things, and we'll talk about that as well. And so on the right, we've essentially compiled exactly what the paragraph on the left is into Japanese. So that's like we pass the text that's on the left through a compiler, and now we have this new thing that someone else can read. Ideally, I mean, when we're doing this, that's a machine, that's a computer that will be able to read that. But that's what compilation is. So it's important to note here that compilation, a compiler does, it runs through and it scans the entirety of the code at once, and kind of does it all at once. So if there are any errors, if there are anything that's wrong with it, compile languages are great because it lets you know that if there are issues, it lets you know that before you are actually running the application, which is kind of nice. A little hard to debug, but it's kind of nice. But it does the whole thing at once. And so a compiler, as opposed to an interpreter. So interpreter is more like real life, like a live interpreter. If you go to a game, maybe you go to a soccer game and you're in England and the team, maybe it's an Asian team, and there needs to be an interpreter so that they can speak to the press. So what we have on the left is we have our source code. This is the code that you're going to be able to understand. This is the code that you're going to write, and that is readable by you and your colleagues. Now we have the translator in the middle. Whoops. We have the translator in the middle. This person takes in that information. They know how to speak both languages. They know how to speak the source code language, and they know how to speak the language of the computer. So that's just like if someone knew, again, that person knew English and Japanese. They would listen to the person speaking Japanese, or listen to the person speaking English, and then they convert it from that source language into a target language for the audience, and they would spit it out in this machine readable code, which is it's called binary, and we'll get into binary a little bit later, but it's just ones and zeros, and it'll spit it out like that. But it's important to know for an interpreter, it does this instruction by instruction, or you say line by line, but it does it more so instruction by instruction. So whereas a compiled language does it all at once and can find errors and things, interpreters kind of do it on the fly dynamically, and they kind of just go down each instruction and figure out what to do next, and it really is a compilation. So it really does kind of I guess compile that code down into machine readable code, and it performs those actions. And so some languages that are interpreted are things like Python or things like JavaScript, or things like Ruby. And so these are interpreted languages. These are, yeah, these all get, they don't need to be compiled down into any targets or anything like that. So yeah, so that's a very important difference to note, that compiler versus the interpreter. So compiler happens all at once. It gets compiled down to either machine code or bytecode, and again we'll talk about bytecode shortly. But it does everything all at once, and it catches errors more easily. Whereas an interpreter kind of just does it line by line, and kind of takes each instruction line by line. It doesn't do the whole thing at once, and kind of does it on the fly and converts it into machine readable code. So bytecode, what is bytecode? Bytecode is kind of so it's an intermediary format that source code gets compiled into. So what's interesting about this is, well, okay, let me read the rest. The bytecode is optimized to be interpreted or run by a virtual machine. I hate this definition. Honestly, I think it's a little bit confusing, but what bytecode is, so this is languages like Java, and I think .NET is like this. And I also think, even though Python is an interpreted language, I think Python also gets compiled down into bytecode, but this is an intermediary step. So during the compilation process, instead of getting pushed into binary, it gets pushed into a code that is more readable by machines, but into a different format, so that an underlying virtual machine can interpret it better, or can compile it down again into machine code. So Java runs on something called the JVM, which I believe is a Java virtual machine. Pretty sure. Don't quote me on that, because I haven't read about Java since college. But that Java virtual machine can run anywhere, but that virtual machine actually reads the bytecode that has been that the Java code has been compiled down to. So it doesn't go straight to machine code. There's this kind of two-step process in that. So bytecode. So in the end, though, everything goes from source code. Everything goes from source code down to machine code eventually, no matter what. Like, it has to. That's the only way the computer can read it. Computers can only read really one thing, and that is binary, which is machine code. So remember that. Remember, machine code equals binary. Bytecode is the least of the things in there to remember, I think. If you're having trouble getting through this list, I would throw off bytecode until the end. I would worry about knowing what source code is, knowing that that's the code that you're going to write, that's the machine readable code that you write. I would worry about knowing the difference between compilation and interpreting, and kind of what languages fall under those, and that it all gets compiled down to machine code, which is binary. Cool. So binary, machine code. I have ones and zeros here. That looks very matrix-like to you. We have on and off, this on and off button here as well. So binary, bi meaning two. And this is, what did I put after this? Cool. Let's talk, we're gonna talk a little bit about binary, but I'm not going to fully we're not gonna go over any binary examples. But we're gonna talk about exactly what binary is really quick. A computer runs obviously off of electricity. It's got a processor, it's got memory and things like that. But the way a computer figures out its logic is it runs electricity through transistors, and it runs it through these pathways, and they route logic, and the logic happens through transistors and these channels being either on or off. So a 0 representing off, a 1 representing on, and so that's how the ones and the zeros mean different things. So one's off, one's on, and when electricity is running through it, it's a 1. When it's not, it's off, so it's a 0. And that is how a computer determines literally everything. Everything in a computer gets kind of boiled down into those ones and zeros, and billions of ones and zeros go through a processor per second, and it makes decisions using that information. If you take a really small, I'll show you later, when you take a small application and it's a compiled language, and you go ahead and compile it, it actually gets pretty large, because it turns into lots of ones and zeros for the computer to use. But that's all binary is. There's a podcast I'm going to give you guys later called the Base CS podcast, which will go deeper into binary for you. It's not. The only reason I'm not covering binary deeply is because I don't think it's important for you to understand binary to really understand how to code. It's not really all that important But it is something good to know. It is something just good to have in your back pocket, and it will help you understand things like bits and bytes as we get a little further along. But we can talk about a lot of that stuff as the time comes. Looks like somebody posted a video. We'll check that out. Technically higher low voltage. But yes, yeah, it is technically higher low voltage. But on off, I find is easier for people to kind of remember. Just because the ones and the zeros. But yeah, binary is cool. You should definitely check it out. You should kind of learn how to count with binary. It's actually pretty simple. It's a little confusing at first, but it's actually pretty simple in the way that works. But cool. So just like that, we've gotten through a fair amount of stuff. But cool. So let's go. We talked about compiled versus interpreted, but let's just talk about what the kind of pros and cons are. So a compiled language just because you are taking care of that translation at compile time. When you go ahead and you run that program, it's very efficient, and it's very fast because it's not doing any of that logic, any of that compilation down to machine code at runtime. So generally compiled languages are much faster, like a whole lot faster, and we'll definitely get deeper into that as the evening goes on. Silly errors are caught at compile time, specifically type errors, but if there's logic, that if you have unused variables, and we'll talk about don't worry about not knowing what variables are right now, but if you have unused things in your code, like if you said, hey, I'm gonna be using a chair in this code, but you never use that chair, compiled languages kind of let you know that, so that you don't have extra cruft in your code base. And yeah, again, they catch a lot of errors, and we'll talk about type errors a little bit later. Yeah, and then due to that efficiency, compiled languages, they're less strained on computer requirements, so they're usually less. They tend to be less of memory hogs as well, because of that. And again, I said static typing. So static typing is it's not actually typing on the keyboard. We're absolutely going to talk about types tonight, and just remember that compiled languages, all the ones that I know have they're statically typed. They have static types. So some pros to interpreted languages: because you do not have to recompile your code every time you make a change. So compiled languages, you write some code, you compile it down into basically an executable or a target, and then you can run that code. Things are a little bit different nowadays, but that's essentially the idea of it, and that can take time, especially if you have a large code base. Compilation can take hours, but most of the time it's pretty quick for most things you're going to be working on, but it can take a long time. So every time you make a change, you got to go ahead and recompile everything and test it out. Interpreted languages, because again, those are done on the fly. It's kind of line by line, interpreted on the fly. Code changes can be made very quickly because you do not have to recompile the code once you decide to make a change. So that's pretty important. Generally, debugging is easier in interpreted languages. We will absolutely talk about debugging a little bit later. But when you run into issues and you're trying to figure out what the problems are, debugging is usually a lot simpler in interpreted languages. Again, because one, you don't have to recompile it, and just kind of the flow of interpreted languages makes it a little bit easier to find out where the errors are. And it has dynamic typing. I don't think that's a pro, but there are situations where that's a pro. Dynamic typing meaning it's deciding whether or not you have type errors or whether or not types can be used. It's doing that dynamically at runtime rather than compile time. It also does something called type inference, so it'll try to figure out what a type should be to kind of make things work. Sometimes not all languages do that, but a lot do, and we will get deeper into that after this. So let me read some of the comments. Like me saying that I found Java hard as hell in high school. Absolutely not. You should not at all be concerned. Java is hard. So compiled languages tend to be much more difficult to learn than interpreted languages. Why? Because of the strict nature of them, because of how efficient and fast they are once they're compiled down. They kind of don't give you a lot of the... Actually, I don't want to say that yet. it's just the structure of them tends to be a little more intimidating, or a lot more intimidating actually. Java was the first programming language I learned, and I had a really tough time learning it. But when I learned Python after that, learning Python was actually really easy. So Python's interpreted, and it was easy, I think, only because I learned Java first. And this is one of the reasons why we're going to be going with Golang. There's a slide later to kind of show that point, but absolutely Java is very difficult to learn as your first coding language, like very difficult to learn. There's a lot of concepts that you have to pick up to do compiled languages really, like understanding like static types, understanding how types kind of fit in. When you're first learning, I'm just trying to think back to when I was learning, it was a very difficult concept for me. It wasn't super easy, so do not feel bad that you didn't like Java or you didn't understand Java. The fact that you were learning in high school is a big deal, and it should make it pretty easy to, when you're kind of hitting some of the stuff that we're doing now, to learn. Yeah, we're gonna go all over types. Why Java programs? No. So Java, the JVM is both great and terrible. So Java has this Java virtual machine that can kind of run anywhere. That's the best part about Java. You could write it once, runs on really anything that the JVM can run on. Java programs tend to run crappy on things for a number of reasons. They can be memory hogs. Like I said, in here I wrote a lot of they tend to be less strained on computer resources. I've also found that Java programs to be memory hogs, to be CPU hogs sometimes. But it also has a lot to do with the way the programs are built. Code quality and code design decisions when creating an app can all lead to those things. And Java is like, it's everywhere. Like, so many things written in Java that you're gonna see a lot of things that are written very poorly with Java, but there are a lot of things that run extremely fast in Java as well. Let's see, 54 X. We have classes like this I don't think we did. So somebody asked about having classes like this at DM. DM is DeMatha. DeMatha is a pretty dope, might be the dopest high school in the country. It's down here in Maryland, private high school out in Prince George's County. It's pretty great. If you have kids and you're thinking about sending them to a dope high school, send them there. It is all boys school though, so you got to have a boy to send them there, but it's a pretty dope. But we did not that I know of, I don't think we had any class like this. I didn't learn anything about programming until I got to college. Cool. So let's hop on to the next point. What's next? The types. We just talked about types. Types are important. And I told you last video that it was important that you know that I'm a 90s baby. That means I grew up during Pokemon. Like, Pokemon is like, it was my life. Like, right now, I'm not as big into Pokemon. I'm not playing Pokemon games. But it's still, this is all nostalgic to me. I love Pokemon. But types. So if you understand types in Pokemon, you can understand types in programming. So types are exactly what they sound like. They're different. They're different categories, different entities, really, in a programming language. A lot of types cross. Almost all programming languages have a shared subset of types. Some have there are some fringe types and different types that are specific to different programming languages, and we'll talk about some of those. But again, just like we have bug Pokemon and dark type Pokemon and dragon type, fire and ice, they're all Pokemon, but they're all different. It's kind of how types are. So we'll just talk about some of the common ones here. So we have strings, and so whenever you hear string, this is really important. String types are very, very important. So this is just kind of the basic ones. But whenever you hear strings, think words and sentences. It's a list of characters all together, but think words and characters. And I'll show you some strings in code shortly. Very important to know. Integers, ints or integers. These are, if you remember your math class, that Matthew said you would never use again, is important. Integers are whole numbers. And it's important to know when you need an integer or when you're using an integer. Integers are whole numbers, and that is a common type to pretty much everything. Then we have Booleans, and those are true and false values. That's all there is in Booleans. Those are very important. Then we have floats, and I probably should have put floats. I probably should have put floats underneath integers. This is another number type. Some languages have tons of number types. These are the two main ones: integers and floats. Integers are whole numbers. Floats are decimal numbers. They're incomplete numbers. They're decimals. Sorry, I don't know why I said decibels, but yeah, decimals. They and those decimals, those floats, they are different from integers, and the way that those two types interact is not the same amongst all programming languages. And there's some caveats in there, so it's important to know that those are two different types. One's flying and one's ice type Pokemon. That's the difference between them. Then we have arrays. Arrays. I put slices in there just because we're going to be doing some Golang stuff, and I kind of want you to equate these two. But arrays, this is an iterable collection of items. So this is, imagine we have we got a little bucket here, and we've got a bunch of different strings in here. So strings, I told you, a list of characters. Maybe we have the word cat, maybe we have the word dog, maybe we have the word parrot, but they're all in this collection. They're all housed in this little collection, and it's iterable meaning you can move through it. You can go through it. So they all have a spot. We have these three things in this, and they all have their place inside of this little collection. And that's all an array is, and I think it'll make more sense to you once we kind of get into code and do it. But these are some of the basic types. There are a lot more types. We will go over those things, especially in Golang, because Golang is a statically typed language. We will have to specify the type of everything that we're doing. When we say, hey, we've got this cat, we're going to have to let Golang know of what type. Is this cat an integer? Is this cat a Boolean? Is this cat a string? We're going to have to let Golang know that. So types are really important. Make sure that you read up on types. I do have a link for you all for reading up on types as well. Cool. So what we talked about, dynamic typing versus, now that you know what types are, we talked about dynamic typing versus static typing. So what is dynamic typing? Types are evaluated at runtime. So runtime being when the actual code is run versus compile time. So compile time happens when you write the source code and you compile it down into machine readable code. For an interpreted language, dynamic typing happens when you run that code. So it doesn't get compiled. Well, it doesn't get compiled down, but when it's doing that translation line by line, the typing gets evaluated. So the evaluated runtime. So if there are any errors, you don't know until you run that program. And sometimes that's important. I mean, sometimes that's great. Sometimes it's not. I usually think it's not a good thing, but everyone kind of has their opinion on that. But that's when types are kind of evaluated. In a dynamic type language, also may try to infer the type in order for the code to run properly. So what does that mean? What does it mean by inferring a type? So if we have a type 1, actually, what do you think if we just had this number 5 here? I haven't shown you that yet, but right here in this example, this number 5 would be of type integer. We're saying it's a whole number. Got that here. We're gonna say this is of type integer, and this example is in JavaScript, and we'll do this live really quick. And if you try to add that to the string of 5, so whenever you see quotes, whenever you see a quote, single quote or double quote, you should be thinking string. Always be thinking string when you see quotes. So this 5 is not the same as this 5. First 5 is not the same as the second 5. Integer, string. In JavaScript, if you try to add those things together, it will give you the string of 55. So it'll take what you're doing and it'll try to infer a type of this first 5, and it will do some what's called type coercion, and it will get it to be 55. Now you got the string of 50. We all know 5 plus 5 should be equal to 10. But if these are two strings and you want to add two sets of characters together, it will be 55. That you just slap them together. And so this exact reason is why I prefer statically typed languages, because you don't run into errors like this. JavaScript thinks I want 55 when I really want 10. But yeah, and I could show you that. We can show you that real time. So let's hop into a terminal. So I'm gonna open up this terminal here. JavaScript is a language that runs in the browser, but there is a programming language called Node.js, which is server side, which allows you to run JavaScript outside of a browser. And when you run it, you can kind of drop into this, because it's interpreted. You basically drop into an interpreter, this little shell that's going to interpret the things that we do real time, so we don't have to compile it. So if I do 5 plus 5, it's going to give me 10. It's smart enough to know that both of these are integers, and it spits me out a number because that's what we gave it. But if I do this, now you can see, and it has the quotes around it. Now you can see that it spits out a string of 55. Remember, you see quotes, think string. The double quotes in this situation are no different than the single quotes. I probably should be using single quotes here as to not confuse anyone. Cool, 5 plus 5 equals 55. And that would be the same thing as if we did this. Now they are two strings, and now they are set up like, so maybe I can show you a Boolean value here. Some of the other values. If I do 5, is 5 greater than 4? So if I want to check if 5 is greater than 4, I put that in there. Programming languages are smart enough to know that, or are programmed to know that I want a Boolean value out of that. So what we're doing right now is something called a comparison operator, and we're comparing what's on the left to what's on the right. So we're gonna say is 5, basically, but what we're doing here is basically saying is 5 greater than 4, and it's gonna kick back true because it is, and that true is a Boolean value. If I use true as a Boolean, I wouldn't be able to like combine it with other things. And obviously, if we switch it up, we get false. Yes, this is a mechanical keyboard. This is like a Cooler Master Keys Pro S, like 10 keyless keyboard. So it doesn't have a number pad, but I have a lot of mechanical keyboards. I went through a phase where mechanical keyboards, like I discovered mechanical keyboards and I couldn't stop buying them. They're very expensive, so don't accidentally get into a mechanical keyboard buying phase. It's about time to get rid of this one, to be honest, to try something new. But it works. I game on this computer and it works well for my gaming purposes. But yes, it is a mechanical keyboard. Hopefully it's not too loud. I actually never even considered the volume of it in the mic. If it gets too loud, people let me know. I have other keyboards that I can swap it out for. But yeah, so just in here, we have 3 different types already. We have an integer, we have a string here, and we have this true false value. And let's hop back into here, maybe see if there's anything here. I won't show you, actually I can show you. If you guys hear some noise, there's some people setting off some fireworks outside, which is a common occurrence around here. I just had to take off my my headphone just to make sure that's all it was. I do live in Baltimore. Baltimore's a great place. Don't talk bad about Baltimore. But I just had to be positive. The dog's not here right now. She's at the vet, so I gotta. She's not protecting me right now, so I gotta make sure that that I'm good to go. But yeah, so let's do 5 divided by 3. What is it gonna give me? Cool. This is a. You can see this is a different color. Oh no, it's the same color in here. But yes, this 1.66667 is the same. Actually, I mean it's not the same type as this 10. They are 2 different things. This is a float. This is an integer, even though they're both numbers. I think I will be able to add them together here in JavaScript. But yeah. Yeah, no Be More slander. None of it will be allowed in the chat. I've grown. I'm not from Be More. I used to slander Be More before I got to Be More. Now that I'm here, I love it. I won't let you talk about it, at least not to my face. Be More's a great place, honestly. Definitely check it out, Cool. So we talked about a couple of types there. Let's see. Let's get back into. Here we go. Cool. So that's dynamic typing. Now let's talk about static typing. This is what I love. Static typing is near and dear to my heart. Types are evaluated at compile time. So this happens before we run it. We write the source code, we compile that code into machine code, or into an executable that the machine can read. And they're evaluated at compile time, and therefore they present errors during that time, before the applications run. And types are explicit. There's no type inferencing. If you want to change types, or if you want to do anything, you've got to do all that type coercion yourself. So in Golang, if I run the same thing and I run 5 plus 5 equals, or I try to run 5 plus 5 integer plus 5 string, what does it equal? I get this entire error down here, and it tells you exactly what's wrong. It looks like there's a lot of extra stuff in here, but it says, hey, cannot convert 5, which is a string. You see the quotes mean strings. I cannot convert 5 type untyped string to type int, because it knows the second thing is an int. So invalid operation, 5 plus 5, mismatched types, string and integer. So they need to be the same for me to do something with them, or I need to do some conversion on my own. And this is very important. Like understanding types and knowing what's going on here is very important. And we'll show you that real time. So let's clear that out. I think I was in here before. So yeah, cool. So, oh no, it just opened up for me. So right now I'm using a text editor. We're gonna talk about text editor shortly. Don't be confused at what I'm doing. I just opened up a file basically to edit. I opened it up in a program called Vim. But this is what a Golang file looks like. And we're gonna try to print out the value of 5 plus string 5 and just show you how it spits out the error. Now, I know we said compiled languages after you change some code had to be compiled. This is true, but they've been built in a way now, and there are tools in place now to where that can all happen without you having to manually compile it. So I could compile this, I could go build this, and it will build me an executable. It'll take a little bit of time, but I can also just do go run, and it will both compile it and execute that for me. So I'm just gonna do that really quick. And interesting, I don't even have Go installed in this virtual machine. That is true. That is very true. And let's see if it installs really quick. Ignore what I'm doing right now. Don't confuse yourself with what I'm doing. I'm not doing magic. It's pretty simple what I'm doing. But I'm just installing Golang on this computer. We'll let that run, and we'll go back to that. I forgot I had everything installed on my desktop because I wanted to show you all how to install stuff. And we will go through that later. See if this cool. Yeah, so you'll see we'll do the example and it'll kick out this error. Cool, then let's talk about some programming languages. So we talked about some of the benefits of interpreted languages versus compiled languages. And so we have a couple of languages right here. This is not an exhaustive list here at all, but we're gonna run through it. So you can see at the top, we've got Ruby, Python, and Perl. You can't see the whole word there, but that's Ruby, Python, and Perl up here at the top. This JS is JavaScript. We've got C, C++, we've got Java, and we've got Go. Hold on, are we having some feed freezing issues? So virtual, I run VirtualBox for virtualization. I also have VMware Player on here. But is the stream freezing? Can somebody confirm? Just so I can make some changes if it is. Check actually. Okay, cool. Thank you. Cool. All right, awesome. Sorry the stream is freezing for you, but cool. Yeah, there's just a couple of them, but what's important here is what this shows here. So fast for humans is this axis, and fast and efficient for computers. So all of these languages here are all compiled languages. So we talked about them being fast and efficient for computers, and you can see how all these are high on that list. But we say fast and fun for humans. So we talk about that source code, that readability. So you can see how Ruby, Python, and Perl, and JavaScript are all up here, very fast for humans to read and to understand and to write, and to understand, but they're not very fast for computers. And again, all of these are interpreted languages. So there's a balance there, trying to figure out what to do. It is important to note that, like, on modern computers, like for a lot of things that you'll need to do, that speed, you probably won't see it. You probably won't really notice it unless you're working on something large. Computers are pretty fast now. And you'll see when we write some JavaScript and Python stuff today, it'll be just as fast, or it'll seem just as fast as the Golang stuff today. But we'll talk about the use cases a little bit later as well. But yeah, so Go, we're using Go because it's kind of the peak of both of these. You know, it's pretty high on the fast and fun for humans list. But it's also pretty high on the fast and efficient for computers. And as you can see, out of all the compiled languages on this list, it is the one that's fastest and most fun for humans. And again, I think it is important for you to learn the rules of a compiled language first, before you hop into an interpreted language. I think it's a lot easier to make that move than to go from Python or JS over to a compiled language and be super duper confused. Cool. I want to learn Go, Ruby, and Python, so this is great. That's awesome. We'll definitely go over that. Python has a number of exceptions to this rule. Yes, that is true. Python's a bit of a monster, and that's another reason why we're not doing Python first. Even though Python is a good one for you to like, it's a good language to learn, learn the concepts with, just because it's very readable. It's pretty simple to get up and running. But yeah, Java is a good language. I don't like, because I deal with like this, usually managing the systems. I don't like managing and deploying Java applications, but Java is a great language. I think there are better options nowadays. Like that JVM is kind of, due to like Docker and like container technologies, I think that JVM is it's not quite as important anymore. But yeah, Java, there's nothing wrong with Java at all. There's still tons of jobs for Java too, like just because Java was so big. But I don't think people who are picking up new projects and companies who are picking up new things, I don't think most people are using Java for that. You can also use Java to build Android apps as well. So if you're interested in mobile app development, Android is good. Java is good for that as well. But so we'll click on this. And so this is a cool website. Let me share this in the chat if you all want to check it out. Get out here. And so this is just, again, exactly what it says, the top 43 programming languages, when and how to use them. So let's take a look at, so we talked about Java just now. Popularity, very high. Again, Java basically ran the world for a few years. And you know, there's still so much that's built with Java. There's still so much that that needs to be supported with Java, that there are a lot of jobs for it. Ease of learning, we got at moderate to difficult. And again, that's why we're not starting with Java, because I find it difficult to learn as well. And what are the use cases for it? Web applications, mobile, embedded systems. So a lot of stuff. There's some history on Java right here. It will be good to read through. So grab the link, definitely go through that. And maybe we'll look at some of the other ones on here. So let's look at Python. Lots of popularity, is very high as well. Lots of jobs for it. Easy to moderate to learn. Again, we talked about how it's a lot easier to learn than most of the compiled languages out here. And it has a similar suite of general uses. But one of the big ones here is for artificial intelligence and machine learning. There have been a lot, because of Python's general purpose, use case. It is there's a lot of packages and things that have been built for various scientific computing things. So artificial intelligence, machine learning. There's a lot of stuff for if you want to do web scraping, there's packages for that. There's kind of things that have been built around Python to really do a lot because of this. It's kind of general use capabilities. Again, easy to learn. It's something that's easy for people to pick up, so that's something that's very appealing about it as well. But yeah, Python's dope. What's the difference between? There's definitely music in the background. If it's too loud, I can turn it down, or if you don't like it, I can cut it off, for sure. It's nice back there to keep people from falling asleep, but if people don't like the music, we can absolutely cut that off as well. But yeah, let me know if you can or can't hear it. But yeah, Python's dope. What's the difference between an intermediate and principal programmer? I heard that term a lot. Okay, that's an interesting question. I think this falls along a lot of disciplines when you're looking for a job. Principal, generally, in my experience, principal means the senior engineer, like not necessarily the lead, but the senior engineer, a senior engineer on a project. Um, yeah, I mean that's all people usually mean when they say principal. It's kind of a swap out term for senior. I guess maybe it could be considered a little bit higher. But yeah, intermediate. Intermediate. Honestly, I think once you've got a solid year of experience in a coding and a programming job, I think you're an intermediate developer. Most people naturally become that intermediate developer. I think you can sit into the intermediate level for a long time, though. I think you can be in the intermediate level from years 2 to 10 if you aren't diligent about picking up new skills and like learning new things. But I think that intermediate job post, that job posting, is for most people. It's you are no longer entry level. You've basically worked a programming job. I think once you've worked one, you fall into that intermediate one. But cool. Let's see. Yeah, so Python's cool. And let's go to Ruby. Popularity is high instead of very high. I think demand for Ruby has been falling in recent years. Ruby's also easy. It's kind of like, I kind of think about it like Python and its ease of learning. You can make web applications with it. They've got a huge framework called Ruby on Rails that you might want to check out. So Ruby's pretty cool. Yeah, again, use it for web applications. You use it for scripting. And there's a lot of DevOps tools that were built in Ruby. Chef probably being the biggest. But yeah, so there's a lot of tools built in Ruby. Ruby's cool. I wouldn't, if you're looking for a language to learn, like if there's a reason you want to learn Ruby, absolutely learn it. I would choose Python over Ruby if like you just want to learn how to code. I'd probably choose Python over Ruby, or JavaScript, to be honest. Yeah, Chef is built for Ruby, and Chef cookbooks you can write Ruby directly in. That is one of the things that I like about Chef. Apart from all the other configuration management platforms, that like you need to hack something together, you can just write Ruby straight in the cookbooks, which is pretty nice. AWS, Docker, Jenkins. Are these some skills? Skill set. So much to learn. Yes, they are. They are great things to learn. We will be going over all three of those things. Yeah, it's a lot to learn, but they all do very specific things. And I think that's what makes it easier. Once you understand the problem they solve, I think that's what makes it less intimidating, rather than focusing just on all the technologies. Focusing on the problems they solve, I think will make it easier to like understand why you need to know all of these things. Yeah, colleges. So I think one of the problems with the tech industry, the disconnects between the tech industry and colleges, are that the tech industry moves so fast. Like a lot of the things that I was doing 4 years ago are like, they're obsolete now. Like there's like things that like people still do, but like they're not the hot thing. They're not the thing that people are paying for. And so that's the tough part. Like for when you're taking a program that's, that spans over 4 years, tech can be completely different once you get out of school. So I would say programming and coding is probably the best one, because those concepts kind of stay a little more stagnant. Like once you learn those concepts, you can kind of find your way around it. But like in terms of like specific technologies and things, it's hard for schools to kind of keep up. Yeah, and then that theory, absolutely. Like I did not go to school for computer science. I went for information systems, and so I've been teaching myself computer science over the past like year or so. I do wish I would have had a little more of that experience and those things taught to me. I do think they've been very valuable in helping me learn how to program better and to code better, for sure. Yeah, cool. So, and actually, since we're going to be doing, let's look at JavaScript real quick, and then let's look at Go, because since we're using Go, is JavaScript really not in here? JavaScript. Oh, it looks like there's a bunch of them. We go to, it's got to be, yeah, cool. So JavaScript. This is probably, if you just want to, if you don't care what you're doing and you want to code, like all you want to do is code, you want to get a job coding, you're not sure if you want to be a software developer, a web developer, or what, this JavaScript probably has the lowest barrier to entry. There's like, everyone's looking for JavaScript devs, which is, you're going to be doing web development. JavaScript is a web language. It has nothing to do with Java at all. They should have named it something else, to be honest. But yeah, ease of learning. I'm actually moderate, sure. I think it's easy to learn. There's some great tools for it. Actually, there's the nodeschool.io. And if you go to nodeschool.io, and I'll paste it here, there's these JavaScript workshoppers. One's called like JavaScripting. Yeah, you install this, and you can kind of run through it, and it'll teach you JavaScript 0 to hero. If you want to learn Node.js, you can do Learn You Node. There's some other cool stuff here, but it's a good resource. But JavaScript's cool. A lot of people are looking for it. It's pretty. The syntax of it is pretty good. It's pretty easy to write. It's fairly easy to read, kind of in a standard form. But there are tons of frameworks and packages out there for it, which means you can build things really fast. That has its own, caveats as well. But JavaScript is cool. And then let's look at Golang. Cool. So the popularity says low, and in comparison to the other things, Golang's popularity absolutely is low. But it's also a relatively new coding language. Again, they say it right here, new kid on the block. It was introduced in 2009, but I have another article for you. Golang developers are getting, I think, the second or third most highest salaries for devs, but it's also big in the DevOps circle because it's what's considered to be a machine language. So it's made to run on systems and to do write a lot of automation with it. A lot of DevOps tools are written in Golang. Kubernetes is written in Go. Terraform's written in Go. A lot of things are written in Go, and it's a great DevOps language. It's a great general purpose language. And again, I think it's the best language for us to compiled language for us to learn that will both be readable as well as fast on the computer. Do I have a YouTube channel? Yep. If you do, oh, looks like somebody did it for you. Yeah, perfect. Yeah, I do have a YouTube channel. The goal on the YouTube channel is going to be a release for now to drop a video every Friday. So I do have a video coming out on this Friday. Yeah, YouTube is a lot harder than Twitch. I actually like Twitch a lot more just because I don't have to do anything. Like, once I set up the lesson plans, like, I don't have to do anything after that. I don't have to do any video editing or recording or feel like I'm, talking to the camera and like watching it back and looking stupid and feeling stupid. Even if I feel stupid, like, once it's happened, so it's no big deal. But I'm definitely gonna start getting some YouTube videos up. There won't be a lot of tutorials on YouTube though. A lot of tutorials will remain on here. I'll be doing workshops and things, so those tutorials will remain here. And the YouTube channel will be more to focus on the bigger concepts, and like demystifying some of those larger concepts and stuff. Cool. So we talked about Go. So maybe let's start writing some stuff. What do we have here? Anything after this? Oh, yes. But how do we even write code? So we're gonna get into this really quick. You need a text editor or an IDE. What's a text editor? It's exactly what it sounds like. Microsoft Word is a text editor, but text editors, when we talk about text editors as far as programming languages and coding, these are editors that are designed to work well with coding languages, and they give you a lot of cool features to help you write code. And we have IDEs here. This stands for integrated development environments, and these generally are used for compiled languages, but there's one for pretty much everything. There's definitely one for Python and Ruby. There's some for all of these, but what they do is they provide a complete suite of development tools for a coding language. Usually they're language specific. Nowadays they kind of have plugins so you can do other things, but usually they kind of tend to cater towards one language or another. I feel really bad because I left one of the biggest options off of here. Yeah, so IDE means integrated development environment. So it just means it has everything that you need. It's got all the tools, all the greatest stuff, so that you can develop, usually in a specific language. But yeah, one of the biggest ones I left off of here is Atom. We're about to check out almost all of these. This one is Sublime. Sublime is a pretty dope text editor that's been out for a long time. Kind of losing steam because of this one right here. This is the big boy, Visual Studio Code. This is launched by Microsoft. This is their open source text editor, and it's very good. Like you usually want to hate on Microsoft products. It is amazing. It runs on all systems. So VS Code is going to be the one that we're going to be using throughout this process. So I'd encourage all of you to try all of these things. And I'll give you a list of some more, but VS Code is the one that I'm going to be using. I think it has the best balance of features and ease of use and a great UI and stability out of all of these. Well, that's the one we're going to be using, but you can also check out JetBrains. We're going to go to all these sites really quick. JetBrains has a bunch. It's paid IDEs, so they have integrated development environments for pretty much all the major languages. They've got them for Java and C# and Python and Golang. But their products are cool. You can get them for free if you have I think if you have like a college email or an education email, I think you can get these for free. But yeah, we're also going to dive a little bit into Vim. Vim is the one I hopped into before. It is a text editor that runs inside of the console. And you can use, if you're on Windows, you can use Notepad++. If you kind of like that, that will work. But I recommend downloading one of these options. And then there's one called Atom. We're definitely going to go to Atom. I completely forgot about Atom. Atom is a text editor built by GitHub, built and maintained by GitHub. If you don't know what GitHub is, it's arguably Git is arguably the most important technology to be created that has to do with the software development lifecycle. And GitHub is basically where the world's code lives. But yeah, so cool. Let's check these out really quick. So open up Atom, VS Code. Let's open up Sublime. I think Sublime, like you're supposed to buy a license, but they give it to you for free, and they just give you a pop-up like every so often if you don't buy it. What else did I have on there? IntelliJ. This is JetBrains, and I'll show you Vim. I'll see. Atom's the best. Atom is good. Atom is just slow. In my experience, Atom is like slow to open. But Atom, besides that, once it's open, Atom's pretty good. I use IntelliJ. PyCharm is great. Yeah, PyCharm is amazing. There's Visual Studio and Sublime. So yeah, I'm a Vim and Visual Studio user. Does VS have a folder structure UI on the side? Absolutely, it has a folder structure on the side. Notepad++ for XML editing, absolutely. PyCharm, WinRAR, cool. Yeah, so cool. Yeah, so Atom is dope. Let's see if there's any like themes. So Atom's great because it's pretty extensible. Packages and things are easy to install, so you can these new text editors are great because you can add functionality to them, and like you don't know yet why you need to add functionality, but you'll need to be able to add functionality to your IDEs or to your text editors to make them work well with what you're doing. Atom allows that to be done easily. Themes, you can make it look really cool very easily. So yeah, themes are pretty important. But all of these have them. So Visual Studio Code has them. Sublime has them. They're all great. But use them all, find which ones work for you. And I would also check out the ones that JetBrains has. Definitely give them a look. Like you don't need an IDE, but they do have good tools that really help. If you're gonna be spending a lot of time programming in a language, I would give these IDEs a shot. But yes, I'm going to be using Golang again specifically because I think learning a compiled language first is great. So let's write some code in a lot of things. So first, let's open up. Let's actually make a folder. So ignore. We haven't got to Linux stuff, so ignore what I'm doing now. I'm gonna make a directory called stream code. All right, I'm gonna open this up in VS Code. All right, so this is Visual Studio Code. I think I already added some extensions to it. Let's close this. Let's close this. So cool. It's a text editor, just kind of like Microsoft Word. And so what I can do is I can open up a new file. Open up a file in stream code. So we're in the stream code directory, and let's just go with the first program you usually write in a language is the Hello World program. Tonight, I think we're gonna write hello, my name is whatever your name is, as our first program for all the stuff. So just so you can see the differences between a language, kind of how they run, we're gonna do this in a couple different things. So first, let's do one in let's do hello world .sh. So we'll do one in bash. We'll do one in hello world. And so this will also show you how to install new packages and things, and show you guys kind of syntax highlighting and great things that these text editors have in them. So we'll do one in Python. We'll do, actually I should have made them all different names. Do this so that it's not hard to run. Let's just call it Python hello world. We'll leave that one. We'll do Golang hello world .go. And you can see here it puts these extensions on the side. So I did one in Python, and it throws in Python. Python's icon here is smart enough to pick up what languages we're going to be using based on the extensions. So it's got a lot of cool stuff. So I'm just going to go to install all really quick. I'll install these extensions. So it gives you some cool extensions to install. I'll let it do what it needs to do so that we have all the packages that we need. I can let that run in the background. Let's also do say Ruby hello world.rb, I think is the file extension for Ruby. And you can see it puts a little Ruby icon here. Pretty cool. Go ahead and install that. We'll talk about linters later. That doesn't matter. A lot of errors here. What else we got? So we got Go, we got Bash, we have Python, we have Ruby. Let's do JavaScript. JS world. Cool. Yeah, okay, cool. So let's start to write. Let's start with JavaScript. So actually no, let's start with Python, because Python is the easiest. So the first program that people usually write is this hello world program. It is basically a program that just prints out the words hello world to the screen. And so you can see how that would be a great first program to run. Very simple. But yeah, so we're gonna print hello, my name is Aaron. So you don't need to download VS Code. I encourage you to download VS Code. I encourage you to try along with me. But I still think you can, for the stuff that we're going to be doing today, I think you can still understand what's going on without having it. But absolutely, go ahead and download it right now. To get it, I can post this in the chat. Head over here. You can head over to this link, and you can download whichever platform you're on. They have it for Mac, they have it for Windows and Linux, and you could just download it, click on it, and click on the thing to install it. It's just a normal program, just like your web browser. And once it downloads, it'll install, and you can double click on it. But it's okay if you don't have it right now. So all we did right here on the left is we created 5 different files. We have 5 different files, all using different programming languages. And right now I just want to show you how differently, how programming languages are all different, but really they're all the same. The concepts are very similar amongst them. And so I just want to show you in a bunch of different ways how we can So cool. So let's do it in Python first. So we're just gonna print. The way you print in Python is just the word print, and I'm gonna say hello. My name is Aaron. Exclamation point. I'm gonna save that. And so that probably doesn't look that crazy to you. The word print and the string. Remember, we talked about strings. I'm saying hello, my name is Aaron, and you can see here that it's showing me that it's a string. This is the great thing about text editors. str, short for string, and it's just saying that it's short for string. That it's a string. And if I try to run that, Python, and I run this file, and it prints it out for me. So I do think quotes. Oh yeah, for Python 3, actually. Will this run? Let's check. Okay, cool. So what's your name? So Matt Z4 Pro put there. So by default, there are two versions of Python that kind of still run alongside of each other, which I think they're shutting down development on Python 2. But this example is with Python 2, and when I run it, it works. But if I try to use the newer version, Python 3, the syntax is wrong, and it won't let me do it. And all I've got to do is put this into quotes, and if I run it again, it works. And I think this is backwards compatible. So it's from Python. Yep, it's backwards compatible. So this is how you run your first program. It's that simple. So no matter what I make this, if I want to say my name was John, I save it. And remember, we talked about interpreted languages. I change it. We said interpreted languages are easy to make changes and run again because you don't have to recompile them. And I run it again, and now it says my name is John. So that is a program. All it does is it is taking the instructions that we sent it. The instructions are very simple. The instructions are print this. And it goes ahead and it prints those things for us. We could put a lot of prints in here. We could put print, and I am 29 years old. And we can save that. And we can run it again. And again, it interprets what we're giving it, and it says, hey, I know you're saying print hello, my name is John, so I'll do that. And then I see this other statement of print, and it's saying that I'm 29 years old, and it gives me both of those. So very, very simple first program. Let's see what that looks like in other languages. So let's do Ruby. Let's try print, and let's print hello world. And actually, I don't even know if I have Ruby installed, so I don't even know if it'll run. And let's try to run that, though. Let's try to run Ruby. Okay, let's install it really quick, though. So on Linux, it's really easy to install things. I can just do apt-get install Ruby. Actually, I need to become a super user. Don't let this part confuse you. You shouldn't be paying attention to this part at all. But we're just gonna let Ruby install so that we can run that code. Maybe we'll run JavaScript in the meantime. So JavaScript, hello world. So what happens if I try print again? And I try to do print, and I try to do hello world. Excellent. Already we get this underline. And I think you all have used Microsoft Word enough or Google Docs to know that when you get an underlined word, it's probably wrong. And this is why text editors are great. And it tells us right here, we have problems. So ignore this one, but it's basically saying it's expecting a semicolon. We could try to throw that on, but this isn't going to work because this is not the right, we are basically, JavaScript is Spanish, and we're trying to speak English to it. Basically, we're plugging in English to the Spanish program. So we've got to give it the words that it's looking for. We've got to use the right words to get it to do what we want it to do. So in JavaScript, because JavaScript runs in the browser, the place that it prints things out to is the console. And the method to do that is log. So instead of print, we can replace the word print with console.log. And then we can do, hello, my name is Aaron. I'll put a couple exclamation points. And we can run node. independent node. And if we run that, it prints out for us, no problem. So the same, this is the same exact program. And actually we can split it here and go back and look at the, close that. Look at the Python one, and we can see how two completely different coding languages actually look pretty similar. Yeah, they look pretty similar. So let's hop into, and actually we can put a second line. Same way we did that, we could do console.log. And I'm 29 years old. Cool. Let's run it again, and again, interpreted language. It just interprets it as I add stuff to it. Very easy to do, and just like that, it is spitting out more information for me. So it changes exactly what I did. Let's do Bash. So Bash is not really, I wouldn't call it a programming language. Bash is it's short for the born again shell. And so whenever you if you're on a Mac, for right now, Bash is the default interpreter that when you open up a console like this, when you open up your terminal, when you open up iTerm2, when you open up terminal on just Mac and Linux, Bash is what is interpreting those things for you. So when I run commands like ls and I run commands like cd to change directory, these are all Bash commands, and it understands what to do with those things. And what you can do in Bash is you can use Bash files to script all these things out. It's programming. I guess it's programming, but in Bash, the way that you print things out to the screen is you just echo it. So hello, my name is Aaron. And to run a Bash script, I have to do one extra step. Ignore this. You'll learn this piece in the Linux portion of it. It's X. What I just called it. Cool. So to run a Bash script, you just do a // and so that works. Don't sweat it if you're getting confused on how to run the script. It's not important to understand how we're running the script right now or how we're running these programs. That is not important right now. The only thing that's important is to see the differences. One, see how simple it is to basically give the computer an instruction. That's what we're doing here. We'll give it some more instructions shortly, but right now I just want to show you how easy it is to give the computer an instruction and for it to do what we want it to do. And I'm going to show you when I move on to Go how different that is in a compiled language sometimes, and kind of how that syntax looks wildly different. And it can be more intimidating. Just focus on that piece. Don't really worry about how we're running it. Just know that when we are running it, it's doing what we told it to do. It's doing those instructions. And so the last one, let's see if Ruby is working yet. Ruby. All right, cool. So Ruby, so cool. So Ruby did do it. You can see here, listen to a different place. There's a reason why it didn't create a new line, but don't sweat it. It printed out what we put in the Ruby file. We said hello world. We add some exclamation points, save it, and run it again. Now it's got the exclamation point. So it's doing what we told it. It is executing those instructions. Now Golang, this one is different. We have to add, there's a lot more setup here to be able to run a command. So first thing we got to do, specify a package. So package main is always going to be it. So usually when you create a new Golang file, if you have the Go extensions installed in VS Code, it will set all of this up for you automatically. But I want you to see me type this out. Then we have to import a package from the standard library. So we need one called format or funct. This will allow you to format things and to print things. It'll give you some tools to print things, and then we can go ahead and write our code. Got to be in a function. I know this is overwhelming already, but it's got to be called main. And then what we're gonna do is format .println hello world. Now you can see that this is much more confusing than the Python one. let's go back to Golang. You can see this is much more confusing. There's so much more work. Absolutely, there is so much more work. Again, your text editor will probably fill in most of this for you. This is the primary line you're worried about. This line is the same as these lines basically, but it is a lot more work. And so you do have to memorize kind of things like this. And so pretty much all compiled languages have a weird, not weird, but they have a structure like this. They have some things you need to set up first, and they have some things you need to specify first before you can run those things. So yeah, that's the difference, and that's why we're going with the one that's a little bit harder. That's a little bit harder first. But this line right here kind of makes sense. If I show you, I actually don't know how to do hello world in Java, but let's look at this really quick. Java hello world example. Look at Java really cool. And so this is Java. So you can see how this looks. This kind of looks like what we did in Golang. Make this a little bit bigger. It's got some other stuff, and I actually think there's a piece that has to go above this for this. But again, the operative line is this right here, and you can see that basically it's the same to be able to print something. You need to learn whatever that function is that allows you to print. And you need to be able to pass that instruction to the computer, and it will do what you want it to do. So it's not incredibly complicated. We can also do things in all of these. So like the same way we did math before, I can also do that same kind of math. I can do 20 plus 500, so that should be 520, and it will Python. Cool. You can see here it prints out what we told it to print out, but it also does some math for us because we gave it the syntax, we gave it the language, the syntax that it wanted to be able to interpret, and it interpreted that for us. Same thing with Golang. In print line, you can do another 20 plus 500. And another great thing is see how everything is a different color. So it gets very easy to identify what a string is and what an integer is. So strings here are yellow, and remember, strings are in quotes. That is a word. That is a list of characters. Our integers are in purple. Let's see what floats are. Maybe they are also purple. Okay, floats are also purple. So our numbers are going to be in purple. And what if I do false? Our booleans are also in purple. And so those numbers, those colors will be different depending upon which what theme you use. So I could change my theme to anything, and it would give me some different colors. So don't be confused if yours isn't yellow or if yours isn't purple. Your theme will control that. The theme that I'm using is Monakai Pro. I think I was using Ristretto or regular. Yeah, Monakai Pro is what I like to use. I like the contrast of everything. But yeah, so you can see how it highlights those things, and at first that's going to be confusing to you, but over time your eyes are going to start to catch those things, and they're going to help you catch errors, and they're going to help you develop faster. But in Go we can do the same thing, and we can do Go run, and it does that math again for us. So again, we're just passing it instructions. It's not a difficult, it really isn't a difficult thing to do. And now the types of instructions get more complicated, and that is what we're going to be learning through the programming piece of this. We're going to be learning what kind of instructions can we pass to the computer, what can it interpret, how do we have to give these instructions, what format does it want these instructions, how can we string these instructions together to get our desired output, how can we string these instructions together to move data around, and so that's really all programming is. It is figuring out how to provide this computer with instructions, and it really is once you understand piece by piece what it is, it's actually very simple. So let's get a little deeper. we weren't supposed to go over some of this stuff until next stream, but let's dive a little deeper into that set of instructions. So all we did was give it instructions to print things out, basically to pass text to the screen. But we can do that in a couple different ways. So what if we wanted to let's start with the concepts of variables. Let's get into some of those extra things. So the word variable means something can change. I told you guys I was in the cars and motorsports. If anyone out there drives probably a Nissan, you probably have a CVT in your car, continuously variable transmission. This means the ratio constantly changes. So this is something that can be changed. We can use this same concept in programming. We can take something, we can take a representation of something, and we can set that up, and then we can modify that. We can change the value of it. So we can basically say, all right, this is what a car is. We have a car here. And we're going to set that car equal to whatever we want to set it equal to. We can set it equal to the number 5. We can set it equal to a sentence. We can say a car is actually equal to a Cadillac Escalade. That is what a car is. As far as this program is concerned, the word car equals the string Cadillac Escalade. So we can do that. We can do that, and we can use that variable to do cool things throughout an application. So let's actually do this in JavaScript. Let's close this for now. So I could say something like this: let name equals Aaron. Cool. So basically what I did here is I set up something called a variable, and I called that variable name, and I set it equal to Aaron. So now if I want to name, so now instead of, I can do cool things in stringing together these things by, I set up a variable that's equal to a string. Before I was printing out, my name is Aaron, but now I can print out the variable instead. And what happens when we do this? Cool, it prints out my name. So I told it to print out name. Up here we said name was equal to what my actual name is, and it printed that out. And so I could change this to, hello, my name is Aaron. And now it prints that out instead, because this variable is a representation of what's on the right, but that can be changed. So under here I can go name now equals my name is John, and we'll save that, and then we'll print out my name again. So what do you think is going to happen here? We set up name here, and then we printed it out, and so that should give us hello, my name is Aaron. And then we did something else. We don't have a let here again. We'll talk about that later, but like, say name is now equal to now my name is John. Is this going to print out hello, my name is Aaron, or is this going to print out now my name is John? Now remember, we talked about this interpreted language, and it executes these line by line. What do you think is going to happen? Run it. First it prints out hello, my name is Aaron, and then it prints out now my name is John. Again, that's what supports that it's a variable, that it can be changed, that it can be modified. You are going to be using variables heavily throughout your coding career. You're going to be using it a lot to keep track of the values of things, and to modify things, and to make changes, and to figure things out, and to do calculations. So that's a little insight into what we're going to be learning next week. We're going to be learning all that in Golang. I'll teach you a lot of stuff. I'll teach you I'll teach you things about variables, I think constants, and we'll talk about functions. We'll talk about all kinds of stuff. And these are all the tools. These are all the instructions that you can give to the computer for it to do what you want it to do. Let me check out the chat. Something got deleted. Yeah, 5 is just kind of It's kind of there. What's the shortcut key for changing themes? So shortcut key for changing themes is Control KT. I think on Macs it's Command K and then T, and so it comes with a lot of preset options that you can change there. And so it's cool to learn the shortcuts. Let me see here. VS Code cheat sheet. So there's a bunch of them. Oh, because my shirt says 5. So my shirt says 5 because this is actually the shirt from DevOps Days DC, the 5th one. This is the 5th DevOps Days DC. Yeah, I don't really care about number 5. But yeah, DevOps Days, if you can get to a DevOps Days in your area, DevOps Days is a conference that's run across the country, really across, not even just this country, around the world. It's a cheap conference. You can probably find one close to you. I think it ranged between like $80 and like $150, which is real cheap for a conference. Yes, I believe there are DevOps Days in the UK. I actually think I tried to get to DevOps Days Berlin or something. So definitely just Google DevOps Days. It should take you to a site, but a lot of the people at DevOps Days are just learning DevOps or don't know anything about DevOps and are coming to learn. But there's great conversation there. They have these really cool things called open spaces, where you get to kind of sit around, like you get to ask a question. People who are interested in that question get to kind of sit down with you and like talk about that question, and you guys get to have a great conversation about it, and you get to get some really good information out of it that you may not have gotten online or from people you know. It's pretty cool. But let's see, DevOps Days. Yeah, they've got them. They've got them everywhere. They have them. Yeah, Istanbul. Man, they really do have them everywhere. So, so definitely check out a DevOps Days if you have one near you, or if you can get to one. It's a pretty dope conference. Let's see, did I have anything else on here? Yeah. So check out. Actually, I do want to show you all of them really quick. This is Vim is a great text editor because we're going to be because we're doing DevOps, because we're going to be possibly logging in and managing systems. I do want to talk about Vim as a text editor really quickly. It's one that lives inside a text editor. So a lot of times, so servers usually do not have what you see in front of you, which is something called a GUI, which is a graphical user interface. So it doesn't have any graphics. So when you log into it, it looks like this essentially. You'll get dropped into a terminal and you have to manage it from this state. And so how do you modify files? How do you write code? How do you do these things if you do not have a graphical user interface available to you? You have to use a text editor inside. There's a few of them. There's one called Nano that you can use. But Vim is a cult classic for sure. And it's a pretty cool tool. Here's the problem with it. Vim is what's called a modal editor. And so it has modes that you have to move in and out of to be able to do what you want. So if right now I started typing, you can see the first couple things that happened where it did a lot of like weird stuff first. And it started typing because I hit a specific key. And you can see down here in the bottom left corner, right now it's in insert mode, and that's where you can go ahead and insert text. I'll hit escape. Now it's in normal mode, so I can't really do anything. I'm hitting spacebar right now, but it's not putting any space in between. I'm hitting the, let's see. Actually, I think I have some plugins. I'm hitting M key, like it's not doing anything. I hit V key, it goes into visual mode, but there's different modes here. And so this is a very intimidating editor for a lot of people because it's hard to find information about what these modes do and how to use it. It's because there's no graphical user interface. You can't use the mouse here. I can use it on mine because I've set some things up, but you usually can't use the mouse here, which is really annoying. And one of the most difficult things, notoriously, is quitting Vim. There's no X button. You can't just get out of it. Before, when I was in Nano, it told me at the bottom what to do. Down at the bottom, it says a little caret and X to exit. I know that means that the little caret means control, and so I can get out of this because it gives me that information. But when I'm in Vim, it does not give me that information. And so I think that if you Google it, it's one of the highest rated things on Stack Overflow. It's one of the most searched things. How do I exit Vim? It's because you have to go into command mode, which is this, you got to put a little colon here, and then you have to hit a Q to get out. If you want to save, you have to do a W to save first, which means write, and a Q to get out. That's really annoying, but I do encourage, there will be times when you have to use VI or Vim. And while I don't think you should use it, work about getting proficient at it to be able to do some coding in, I do think you should get just proficient enough to be able to edit a text file and save it and quit. I do think it's something that you should look into. It's available, again, it should be available by default on your Mac computer. Even if you're in Windows, you can get Vim installed on Windows as well. Still works. But check it out, see if you can get in and edit some files with it, because we're going to be doing a lot of system stuff, and I think it will help you once we get to that point. I think it'll help you a lot to be able to kind of follow along after. But I think that's about it for tonight. I said tonight was gonna be a little bit shorter. Since this was just kind of the basics of programming. I will send out, I have all the resources ready. The resources will be sent out tonight. There will be let me show you what some of the resources are. Cool. There will be, I'll send you guys I'll put it in here for you to have it, but I'll also send it out via Slack and through social media. But this is the Base CS podcast. So if you want to learn some more of those computer science topics, this is a great podcast. And they basically go over computer science concepts in a very approachable way. They just talk about them in very easy to understand ways, which is pretty dope. And so I would run through that. Any scholarships or waivers for DevOps Days? I think there are diversity scholarships for DevOps Days. I believe it depends on which one. If you go to the DevOps Days website and click on a particular DevOps Days item, I think it should be on there. Let's see. This is the Stack Overflow developer survey that comes out every year. Check this. I think everyone should check this out. No, that's also going out tonight. The link for the Google Classroom. I was waiting until we had our first class where we actually had things to go over afterwards. That will be going out shortly after this to anyone who's subscribed. You'll get a link to access the Google Classroom. This stuff will be inside the Google Classroom, as well as some extra information and resources and tools for you to run through. But this developer survey from GitHub is pretty great. Comes out every year. From Stack Overflow, sorry, not GitHub. Stack Overflow is where you will go to get all of your coding and programming answers. I told you in the very first stream that no one knows it all, but Stack Overflow knows a majority of it. The answer is usually there, and being able to parse Stack Overflow and search Stack Overflow for what you want is a very important tool that you'll need to pick up, and we'll be using that. Yeah, so it's got a lot of stuff on here. So if you just want to see kind of like what people are working on, people's ages, various metrics on, what people consider themselves, how many years of experience people have, like all this information is in here, and it's pretty in depth and it's pretty interesting. I would take some time to run over it and look at it, see, the programming languages that people are using. You can see, even though it said low, it said there was low demand for Golang, you can see here on the developer survey that it's one of the most loved here. So it's pretty interesting how that works, but definitely go ahead and check that out. That will be shared as well. So let's see. Yes, after you download the text editor, you do need to install these programming languages, and that was not the purpose of this introductory to programming course. We will go over fully next stream on installing Golang, installing some other programming languages as well, and getting everything set up. So like, you don't need everything set up for this stream. Next stream we will go through together and get your whole editor set up for that. If you're interested in doing that yourself beforehand, I'll put some videos in the Slack channel. Join the Slack channel. I'll put some videos in there of people kind of installing, getting set up in Golang, so that you can get up beforehand. You can text editors ink again. What were you looking for? Were you looking for the link for how do you get access to Slack? You can do a command to get the invite for that. But yeah, next class we'll go through getting installed. We'll go through getting Golang installed, getting text editor installed, getting all the packages that we need inside of our text editor setup, and then we'll start coding. We'll start working on problems. We'll start going over all of the functionality. We'll start learning how to do those, to provide those instructions. Again, you don't have to use VS Code. If you're comfortable with another editor, go for it. If you want the challenge of trying something else, absolutely go for it. Just if you really want to follow along with what I'm doing, you should download and install VS Code. Again, we will go over that one at a time. But yeah, I'll give you 20 minutes back. Most of these are going to be 2 hours. This is probably the last one that's going to be this short, though. Like, I was looking through the list. They're all going to be 2 hours after this, for sure. Some of them are going to be pretty tough to get in 2 hours, but we will get them into 2 hours. We'll work hard for that. Oh yeah, I'll send you the link for that. For VS Code. Cool. If anyone has any questions, definitely I'll hang out for a little bit, ask some questions. If not, join the Slack, hop into the Slack, reach out to me there, reach out to me on social media. I'll get those questions answered for you. But hopefully you got something out of this. Hopefully you learned a little bit about programming and kind of the overall structure of programs and kind of the different options you have when you are programming and kind of what they do, and hopefully seeing how simple it was to give a computer some instructions. Maybe not so much the Golang piece, but how easy it is to give a computer an instruction and for it to follow it. Hopefully that reduces some of the intimidation for you. But yeah, the slides will be in the Google Classroom as well. They are in the Google Classroom already. Is Golang an extension for VS Code or a different package? So there is an extension in VS Code for VS Code to be able to understand Golang and to like have some tools to help you develop Golang. But Golang is a completely separate package that needs to be installed on your underlying operating system first. So you can Google around, you can try to get it installed if you like beforehand, but we will be going through that later. Go has some weird setups that have to happen, so you may want to wait for that. Actually, if you want to mess around with Golang, if you want to start messing around with Golang and you don't want to get everything installed on your computer, go to the Go Playground. So Google provides play.golang.org. You can go right here and you can do everything that you need to do with Golang. And so this was another reason why I was saying you just needed a browser. There's pretty much a way to do all this stuff. You don't get any cool colors, but what you do get is they give you a hello world basically out of the box. You just click run and it goes ahead and compiles it and spits it back out for you. And I can just change it. Name wrong. And you just click run again and it changes it for you. So you can practice your Golang here. You can practice your Golang here. So do you think it's realistic? Goal of me and see myself enter tech job in November after bootcamp is over with. I would say one, I'm assuming that question comes, one, how much experience do you have? I actually think if you got a good hold of this information, absolutely. I don't think you'll be able to walk, if you had no experience before, I don't think you'll be able to walk into a DevOps job, but I think if you started interviewing for help desk jobs or various tier 1 jobs, and you start talking about, hey, like, I know this much about Amazon Web Services, I understand Docker, and I know Docker does this, and I've done some things with Python. I think absolutely there are tons of jobs in tech that you will absolutely be fit for. In tech, realistic 100%. You run through this, you get a handle on some of the concepts. You don't even have to understand all of them. Just hear about them, read about them, do your best to understand them. Absolutely, I think you'll be able to wow someone with your knowledge and get a job 100%. And for people who have some industry experience, especially if you're already like a developer and you're just trying to learn more about the ops side of things and kind of deeper DevOps concepts, I really think by the end of this, I think for how in-depth we're going to get with the tooling, with the labs that we've set up, I think it's going to give you a good shot at getting a job in DevOps, 100%. So yeah, so Go Playground. Yep. That is all I have for this week. Like I said, I'll hang out for a few more minutes, but if not, reach out to me in Slack. I see a couple people already joined the Slack on the last few minutes. So ask any of the questions that you have there. I'll run through the chat again to make sure if there are any questions that I missed. I'm going to start a channel called like missed questions or something like that. And I'll try to go through and answer all those questions that I missed inside of Slack as well. But cool. Thanks everyone for joining. Again, I'll give you 15 minutes back. It was 20 minutes. I'll give you 15 minutes back now. But I hope to see you back on Monday. I'm going to send out those resources, run over all those resources, read a little bit about different programming languages, do your due diligence and check out some of these text editors and mess around with them and see if you like one better than the others. Yeah, come back Monday, really ready to dive in. Monday is when it gets Monday is the first day you're probably going to be truly confused at times. But yeah, I think it's gonna be a good day. We're gonna be here to help each other, so let's have some fun. But all right, good night, everybody.